Please don't be afraid to use the chat. It's a really nice way for you to communicate with me if you don't understand, or if you want to answer something, or if you want to ask a question, you're welcome to unmute yourself and ask, or if you prefer to put it in the chat, that's also not a problem. I think we should get underway. Michaela, do you agree? Okay, all right, so welcome Matrix. This is our 4th lesson out of 6. Just so that you're aware, the first 3 lessons that we had, the first lesson was on first principles, and the second lesson was on rules of differentiation. So we were talking about what we would do if we had radicals, what we would do if we needed to remove divide lines, how we would write our expression over a monomial denominator, how we would get rid of brackets. And then in the third contact session that we had, we stuck with rules of differentiation, and then we spoke about what would happen if we needed to factorize. Okay, so this is the 4th lesson, and in this lesson we're going to be talking about determining the equation of a tangent. All right, so let's get underway then. I don't know how far you guys managed to get with these questions. Hopefully you managed to do a few of them. All right, so as far as the green question was concerned, can I get a thumbs up from anybody who was able to finish the green question? Has no one managed to finish the green question yet? Okay, lovely, Kanya. Thank you for your thumbs up. That's great. Okay, so Kanya's given me a thumbs up. I think, is everybody else, are you struggling? Is it a difficult question? Is it because there's a pi in there and you're not sure what to do about the pi? Okay, no, okay, no problem, Virginia. Glad you're here. Well done. Thank you. Okay, so Luazi's also given me a thumbs up. Thank you. Okay, so these are the questions from last time. So I don't want us to spend too much time in this lesson speaking about this, because these are skills that we actually are already supposed to have. The answer to that would have been as follows. Okay, so can you see we've kept y equals? We've removed the radical in the first term, so we've written it as x to the power of 3 over 2. Then remember, anything that's in the denominator has to be written in the numerator. And because we moved the x from the denominator to the numerator, we had to change the sign of the exponent. And then 1/2 pi cannot be written in any other way. So 1/2 pi is actually a constant. Pi is a number, as we know. All right, so 1/2 pi would be a constant. So we're expecting that term to become 0 when we differentiate. Okay, so they've differentiated y with respect to x, and they've got 3 over 2x to the power of 1 over 2 plus 5x to the power of -2. So who managed to get that right? I think there's only 3 of you that have done it. Kanya, was that right? Luazi, I think you also, oh, there's a few thumbs ups. Oh, good. Well done. Okay, nice. Now, what about the purple question? Did anybody manage to do that? Zio, you're giving me a thumbs up. Okay, so there's a couple of people. All right, so let's go and have a look at that quick answer as well. This one I think is probably even easier. There you go. That's what you should have done. So factorize difference of squares. After you've factorized, you can cancel x plus 3 with x plus 3 at the bottom. So our expression that needs differentiating is x minus 3, and the answer would be 1. So if you managed to do the purple question, how did that go? You can give me a thumbs up. It doesn't matter if you didn't manage to do it. It's not the end of the world. Okay, lots of thumbs ups coming through. Live, Luazi, Ozayo. Good, great guys, that's fantastic, very nice. Okay, and then just last of all, then we can get started on our lesson. Did anybody manage to do the orange question? So can I have a thumbs up if you managed to do the orange question? Okay, so no one's sending me Zio. That's fine, no problem if you didn't get a chance. what we're going to do is if there's time, we can come back and we can have a look at that, or else you're welcome to write it down. I've given you a little hint there, factorize difference of cubes, and then you can always come back and have a look at that in the lesson if there's time. If other people are still finishing something off, then maybe you can have a think about that. In the meantime, the hint is think about factorizing the numerator, the x cubed minus x, using difference of cubes. Okay, and we'll see if we can come back to it and talk about that a little bit later. All right, let's get on to our lesson. So our prior knowledge check for today's lesson is, what is the general term for a straight line? So I would like to ask Isaiah, can you tell me, or you're welcome to type it in the chat, what is the general term that we use when we're talking about the equation of a straight line? Isaiah? Do you know, Isaiah? No? Okay, thumbs down. All right. Virginia, do you know? Do you know what the general equation is for a straight line? This is not something... Go for it, Virginia.
Ma'am, it's y equals to mx plus c.
Hey, you're a champ. Well done. Perfect. Okay, so y equals mx plus c. 100%. Okay, so now we need to know what the y and the m and the x and the c represent. Okay, so Kanya, do you know what m represents? M.
It represents the gradient.
The gradient, quite right. Okay, so m represents the gradient. So we can write that in here. Let me just get my pen working. Go. All right, so m represents gradient. Why is this not working? There we go. Okay, so m represents gradient, 100%. There we go. Let's fill that in. Okay, and live, do you know what c represents? Live, do you know what's the y-intercept? Good, well done. Sorry, I didn't mean to chase you there. The y-intercept, 100%. Now comes the difficult questions. All right, Neo, do you know what y represents?
Is it the y-intercept?
Y is not the y-intercept, unfortunately. C represents the y-intercept. And this is actually a really important question, and I'm glad I asked it, Neo, because a lot of students really struggle with this, right? X and Y are coordinate pairs of any point that lies on the line, okay? So these two function together, right, the X and the Y. X functions as your input, and Y functions as your output. Okay, so these are the X and Y coordinates of any point that lies on our tangent or on our straight line. Okay, what I've got down here, so it's important for us to know what these things are, because we need to know what to substitute in the correct place, or what they're asking us to solve for in the questions that we get. All right, so I like to call this section, I like to call it 3 magic ingredients. And for me, the 3 magic ingredients are X and Y and M. And the reason that I call them the 3 magic ingredients is because when we have those 3, that's when we are able to solve for C, the y-intercept. So what I've written over here, so the X at T, the Y at T, the M at T, that means the X coordinate at the point of tangent C, the y coordinate at the point of tangent C, and the gradient. Remember, the gradient of the tangent is equal to the first derivative. So that's really important. So with these 3 things, we will always be able to work out our C value. All right, so let's see how this is going to work. Also, before we get started, I would just like to bring your attention to this little pink diagram on the side. And this is how M and X and Y, our three magic ingredients, this is how they are related to one another. So X is like the link in the chain that holds everything together. If we have X, our input, we can work out what M is. If we have X, we can also work out what our Y is. All right, that's the connecting part. So if they give us Y, we first have to work out X, and only then we can get M. If they give us M, first we have to work out X from M, and then we can work out Y. So what I would suggest you do is somewhere just make a little note of that, all right, because you're going to see how that's going to play out in the questions that we're going to do. All right, so let's have a look at the first example. Here we've been given the X. So in other words, we've been given this bit over here. All right, this one, been given X, right? So we have a choice. Either we work out Y first or we work out M first. It really doesn't matter. If I want to work out Y first, how am I going to do that from what I've been given? So X equals -1, and they want us to find the equation of a tangent to this particular cubic function where X is equal to -1. So if I want Y, the corresponding Y coordinate, where X is equal to -1, what am I going to do with the -1? My question is for Luazi. Substitute into the equation, quite right, Luazi. That's exactly what I would do. So I could write Y as G of -1. And I'm going to substitute -1 into my equation. So -3 times -1 cubed plus 2 times -1, subbing it in, minus 3 times -1 plus 5. Okay, and that's going to give me a corresponding Y coordinate of let's ask Virginia. What do you get, Virginia? Did you get 10? Nine, okay. New, you got 9. Why did I get 10? Okay, so the first term is equal to +4. Okay, Virginia, 9. Let me just double check myself. 2 plus 4. Sorry, you're quite right. It's 4 plus 5, which is 9. 100%. There we go. Okay, I also get 9. Okay, so now we worked out what the Y at the point of tangency is. So here on this side, we've got X at the point of tangency is -1. The Y at the point of tangency is equal to 9. So our third magic ingredient is the gradient of the tangent, which is equal to the first derivative. Okay, so now I'm going to have to take the first derivative. So I'm going to say G prime X, and I'm going to derive using my power rule. Okay, so that's going to give me -9x squared plus 4x minus 3. Right, now in order to be able to work out what the gradient is, I now need to sub in the x. Can you see how from x you can get m? All right, so from the derivative we sub in x, and that will give us the gradient. So therefore, the gradient at -1, let's sub in -1, minus 9, -1 squared. And then we would pop that into our calculator and we would end up with, that would be -9 minus 4 minus 16. I agree, Virginia. Well done. Thank you so much for helping me. Okay, so now we've got our 3 magic ingredients. Okay, so we know that the gradient at the point of tangency is -1 over 16. And now we can put these 3 magic ingredients together in y equals mx plus c. So y equals mx x plus c, and now we're going to substitute. Okay, so in place of y, we're going to write 9. In place of m, we're going to write negative 16. In place of x, we're going to write negative 1 plus c. All right, and now we've got to take that term, the minus 16 times 1, over to the other side, and that means the value of c is going to be, what do you get, Neo? Minus 7. Okay, so I agree with you. It would be minus 7. Well done. Good job. So now our final thing, okay? Just put it all together. All right, we've got to answer the question. So our final step is to write it as y equals minus 16x minus 7. Okay, there we go. We're done. Does that make sense? Can I have a thumbs up? How are you feeling? Are you ready to try one? Oh, good. Lots of thumbs ups. Well done. Okay, so here is your question. Good. Thank you. Thank you. Okay, so here is your question. All right. You're going to try this one. Maybe what I should do is I'll try and leave as much of that down there. Can you see that all right? So you're going to determine the equation of the tangent to f of x being x squared minus 6x plus 5 at the point where x is equal to 2. If you are finished, then you can certainly try that orange question from the beginning, or else I've got another one. Oh, you need me to zoom in. With pleasure. Is that okay, even if you can't see everything up above? I can zoom in more. You want to zoom in more, okay. Is that better? No problem, Virginia. Okay, so I'm going to give you guys a couple of minutes to try that, and then we're going to talk about your answers. You want to see the sum above? Okay, one moment. It's going to be a little bit tricky for me to keep this zoomed in. What I'm going to try and do is I'll zoom out so that you can see the sum above, and then I will try and make that bigger. Does that work for everybody? Let's see if we can zoom in one more time. Try zoom in one more time. Is that okay? Okay. Neo, you're done. Brilliant. Well done. Okay. Neo, in the meantime, did you write down that orange question from the do now? You don't know what I'm talking about. Okay, not a problem. What I also did, in case anybody was finished early, is I made you a while you wait. So hang on a second, I'll just grab that. Okay, so Neo, while you wait, there you go. Let's just move it over a little bit. That gives us something to think about. Okay, so yeah, write that one down, Neo, and then you can always come back to it while you're waiting for the others to finish. Good. Okay, please send me a thumbs up when you finished. You should almost be done now. Virginia, good, well done. Another thumbs up. Good stuff. Piwa Konke, well done. Ozayo, nice. All right, lovely. In that case, let's go and have a look at the answers. Okay, so Piwa Konke, all right, what was the first thing that you calculated? Can you tell me? You can put it in the chat or you can turn your mic on. What was the first thing you worked out? XT, okay. Piwa Konke, they gave you the x coordinate at the point of tangency, all right? So that's right, that's the first thing that we had. From there, what did you calculate? Did you calculate the x at the point of tangency or did you calculate the gradient? That's fine. Okay, so you calculated the y. All right. So what did you get as your y, Piwa Konke? -3. Okay, let's see. I agree with you. That's what I did as well. And I got -3. Well done, Piwa Konke. That's great. Excellent. Okay, and what about, nice job. And what about Sake? After you had worked out, did you get the same value for y? Did you also get -3, Sake? Oh, you did. Very nice. Well done. Okay. And then, Sake, what did you get for the gradient?
Mama, -2.
Oh, you are so clever. Well done. All right. That's exactly the same answer that I got as well. Excellent. You guys are just flying through this. Perfect. All right. So then this is what I ended up doing. I hope it's the same as what you ended up doing. I said -3 equals -2 times 2 plus c. I got c is equal to 1. And thus my equation of my tangents, I got y equals -2x minus 1. Did you guys get the same answer? Thumbs up. Kanya, well done. Thumbs up. Iomide, Virginia, Kanya got that. Oh, that's wonderful. Well done. That's brilliant. You guys are just flying through this. Great. 8 thumbs ups. Oh, and a little party. Brilliant. Well done. That's really great work. Okay, so now, all right, we are going to determine, let's move on. Now we've been given y. I hope this is big enough and everybody can see what's going on here. All right, so now we want to determine the equation of a tangent to f of x being x squared minus 2x plus 1. If the gradient of the tangent is negative, so I've underlined that because it's important for us, and the y coordinate at the point of tangency is 4. Okay, so now they haven't given us the x, they've given us the y. So remember our little pink diagram on the side. If we've got y, we cannot work out gradient. We have to work from y to x, and then from x, we can go ahead and go and get m. All right? So now what I want to know is where should I put the 4? So Luyanda, what do you think? Where should I put this 4 that they've given me? What do you think I should write? You're not sure. Well, then it's a good thing that we asked this question. That's fine. Nothing wrong with that. Is there anybody else who thinks that they would know what to do with a 4, where they would put it, where they would substitute it? Quite right, Piwa Konke, f of x is equal to 4, all right? So that means that y is equal to 4. So in other words, we're going to take the 4, Luyanda, and we are going to replace f of x with 4. Okay, so in other words, over here, where we see f of x, that is where the 4 is going to go. Okay, so I've actually done this for you in the hope that we'd be able to get through this a little bit quicker. Let's just see how this goes. Okay, so does that make sense? I have substituted f of x equal to 4. All right, so what I would do now is I would take the 4 over to the other side. I would get it into standard form. It would end up looking like that. once I've taken the 4 over to the other side. And from this point over here, I'm now going to do what do you think? Luazi, what would I do here, do you think? What's my next step, Luazi? Even if you don't know, it doesn't matter. We're talking about it. Sorry, you did not get that. Okay. Luazi, can you see what's on the screen at the moment? Are you okay with the idea that we've made f of x equal to 4 because that is the y coordinate? And what we've done is that we've then rearranged and we've got it into standard form. So in other words, I've taken the 4 over to the other side, and now I've got 0 equals x squared minus 2x minus 3. What do you think my next step is, Luazi? What should I do at this point? Transpose. I've already transposed. I've taken the 4 over to the other side. Because it's quadratic, everything is on the same side and it's equal to 0. So my next step is who can tell me what my next step is? Luyanda? You know what the next thing I need to do is? Ah, there we go. Oh, factorize. Perfect. Yes. Do you use the quadratic equation? Neo, you can. You can, absolutely. But the idea is if you don't need to use the quadratic formula, rather just try and factorize. If the expression factorizes, it's quicker just to factorize. But yes, if you wanted to, you could use the quadratic formula. Nothing wrong with that. You'd have to show where you'd subbed into it. So there we go, Luazi, perfect. There are our factors. So 0 is equal to x minus 3 times x plus 1. And now I have 2 solutions for x. Now, we didn't see that before. Right? We've got 2 solutions for x now. What do we think is the next thing that we're going to do? Right? We've got a y. We've got an x. So now our next step is to work out what the... Virginia, do you know what's our next step?
Should work out the gradient.
The gradient, absolutely. Now, Virginia, am I going to choose to work with 3 or with -1? Am I going to ignore one? I'm going to work with both of them. What would I do here?
Ma'am, I would work with both.
Absolutely, absolutely, Virginia. I've got to work with both, all right? Because they told me up at the beginning, if you guys remember, that they want the gradient of the tangent to be negative. So when I sub into the derivative and I sub in my x, one of my answers will be positive, the other one will be negative, and because they told me to use the gradient where the tangent is negative, that's going to be the one that I select. So in other words, okay, now I have to derive. Okay, so that's what I've done over here. I've derived my expression. My first derivative is 2x minus 2. First, I'm going to sub in 3. Then I'm going to sub in -1. When I sub in 3, I get 4 as an answer. When I sub in -1, I get -4 as an answer. So now remember what we've calculated. When we've subbed into the derivative, we have calculated the gradient. So in other words, this 4 over here, let's just make sure we're using a different color. Let's go with orange. This 4 over here is a gradient. It's a gradient at a point of tangency. This -4 over here is also a gradient. It's a gradient at a point of tangency. So by now we've realized we've got more than one tangent, don't we? There are 2 tangents, one that has a positive gradient and one that has a negative gradient. Okay, so they said to us we needed to work with the one with the negative gradient. So this solution over here, the one where I placed the tick by, that's going to be the one that we will go with. So in other words, the x coordinate at the point of tangency is -1. The y coordinate at the point of tangency was 4, if you recall. And now we've calculated the gradient at the point of tangency, and that happens to be -4. So there are our 3 magic ingredients. Put them together. So as I've written over here, m is -4, x is -1, y is 4. Sub that into y equals mx plus c. So that's what I've done over here. Y is 4. M is -4, x is -1, and c like so. And then that means I can now transpose and I can solve for c. All right, and I get an answer of 0. All right, so everybody happy? The equation of the tangent to this particular function, where y is equal to 4 that has a negative gradient, is the line y equals minus 4x. Okay, so good, I'm glad, Virginia, that's great. Thumbs up, well done. Okay, so now let's move that out the way, and now you guys try one. There you go, that's yours. If you've got any questions, then ask me with pleasure, I'll help you. But this is exactly like the example that we've just done, so it should be quite easy. You can't see the entire question. It's hard to read the question. Oh, I beg your pardon. Does that help? Is it still blurry? Should I read it to you? Is that better, Kanya? Okay, all right. So it says determine the equation of the tangent to the curve g of x equals x squared plus 4x minus 5 if the gradient of the tangent is negative and the y coordinate at the point of tangency is equal to negative 8. And then as before, if you've done it, you can give me a thumbs up. If you're struggling, please do ask. I don't mind. I'll answer any questions to help you. It's not a problem. Okay, anyone got any questions? Anyone struggling? Okay, doesn't look like it. All right. Yeah, thumbs up when you're ready, guys. Well done, Sake, you finished. Good. In the meantime, if you manage to get that other question down, Sake, I don't know if you remember which one I was talking about. It was that sort of difficult differentiation question. You're welcome to work on that in the meantime. Good, Kanya, thumbs up from you. Well done. You can also work on that other question in the meantime, Kanya. Okay, Virginia and Piwa Konke. Good stuff, well done. Can also work on that other question. Okay, so I'm going to wait one more minute. And then we're going to have a look at the answer. Okay, so there've only been 3 thumbs up so far. So live, I haven't heard from you. Leanda, I haven't heard from you. Dwazi, I haven't heard from you either. Neo, there hasn't been anything from you either. Is this a difficult question? Ayomide, okay, sorry, I left you off. I beg your pardon. So you've given me a thumbs up. All right. So there's a couple of thumbs ups now. Okay. All right, I don't know where I put my answer to this. I'm fairly certain I had it around here somewhere. Oh, all right, anyway, it doesn't matter. Okay, so this is what should have happened with this particular question. Let's just fly through this. Okay, so what we should have done here is we should have allowed x squared plus 4x minus 5 to be equal to -8. After that, we would have brought the -8 over to the other side, and we would have ended up with x squared plus 4x, add 8 here, add 8 here, and then that means we would have ended up with plus 3 is equal to 0. Okay, after that, we would have factorized, and our factors would have been x plus 3 times x plus 1, and that means that either x was equal to -3 or x was equal to -1. All right, did you guys get the same answer as me? Virginia, good, lovely. Okay, Piwa Konke, Ozai, lovely, live. Okay, so now live, tell me what happened after this. What happened when you used -3? Did you get a gradient that was negative, live? Did you get a negative gradient? Okay, I don't know if you can hear me live. Anyway, it doesn't matter. If we take the derivative, did we all end up with 2x plus 4? All right, and then we would see, excellent, okay, and then if we subbed in, We subbed in our -3, first of all. Good, you also got that. Would have had 2 times -3 plus 4, which would be -6 plus 4, which gives us -2. Okay, if we sub in -1, we wouldn't end up with a negative gradient. What would have happened here is we would have ended up with 2 times -1, whoopsie, plus 4, so that would have given us a gradient of 2. Okay, so this is going to be the one that we would have selected. All right, so our 3 magic ingredients for the equation of a straight line in this case, our y at the point of tangency is -8. Our x at the point of tangency was -3. Our y at the point, not y, our m at the point of tangency was -2. So now when we want to put all of these together to get the equation of a straight line, let's just do this quickly and then we can move on to the next one. We would have ended up with -8 is our y, gradient minus 2, x -3 plus c. So this is going to give us +6 on this side, so -6 from this side, -6 from the other side, and that would have been -40. So who ended up like me with an equation y equals -2x minus 14? Please, can you give me a thumbs up if you got the same answer? Well done, Ayomide. Virginia, Piwakonke. Good. Okay, lots of thumbs up, 7 thumbs up. Okay, 1 thumbs down. Okay, live, you didn't get that answer. All right. Live, what we're going to have to do is I'll see if I can talk to you on the side, but I just want to carry on with this example, and then we can maybe see where you went wrong and try and sort that out. I hope you've copied this.
Error.
Oh, was it just an adding error? Okay. All right, live. That's not a big thing. Okay, never mind. Okay, I'm glad you know where you went wrong. All right, so let's have a look at the next one quickly, and then we're going to have to maybe treat the next question as our exit ticket. The time goes by so fast. Okay, so remember our magic 3 ingredients. Okay, so x holds everything together. From x, we can get y or m. In example number 3, we've been given the gradient. It says, find the equation of the tangent to f of x equals 3x squared minus 5x plus 1, which is parallel to the line y minus 7x plus 4 equals 0. Okay, so Sake, do you know what the first thing is that we need to do here? Sake, do you know? Even if you don't, it's fine, it's not a problem. No, ma'am, that's fine, not a problem. Is there anybody who does know? Is anybody who does have an idea of what you think we should do now? What's the first step? Malu, go for it. What do you think?
Ma'am, well, personally, I would first correct the y minus 7x plus 4 and make it into a proper equation.
Beautiful.
So
Tell me, that's lovely. Tell me what to write, Malu.
it would be y is equal to 7x minus 4.
Beautiful. Okay, so now, Malu, you're onto a really good thing here. What have I been given in this case?
Your gradient.
Your gradient. Okay, so I know that my m at t, my gradient, my f prime x, f prime x is equal to 7. Good, well done. All right, so now that means I need the x at the point of tangency and I need the y at the point of tangency. Okay, so from my gradient, I can get my x coordinate at the point of tangency. How am I going to do that?
By finding your derivative.
By finding the derivative. Excellent. So what I'm going to do is I'm going to take the derivative, f prime x. I'm going to derive, so that's going to leave me with 6x minus 5. And now, what am I going to make the 6x minus 5 equal to?
7.
7. Excellent. So I'm going to put 7 over here equals 6x minus 5. Is everybody else comfortable with that? Do you understand why I've made f prime x equal to 7? Okay, in this case, I've been given the gradient. Okay, Virginia, you've given me a thumbs up. That's lovely. Oh, and a few more. Iomide, well done. Great. So now I'm going to move the -5 over to the other side. So that would leave me with 12 is equal to 6x. I would divide both sides by 6, and that means that x would be equal to 2. Okay, so what do I have so far? The gradient is 7. X at the point of tangency is 2. So now what do I need? Y at point of tangency. So that means I need to work out what f of 2 is. So subbing that in, 3 times 2 squared minus 5 times 2 plus 1. So that's going to leave me with 12 minus 10 plus 1. So that will leave me with an answer of 3. Good, Virginia. Cool. I get the same thing. All right. So now last step, and then you guys are going to answer this question. I think this is going to have to be our exit ticket. Let's just quickly finish this off. Okay. So now that was equal to 3. So now y is 3. M is 7. X is 2 plus c. So subbing into y equals mx plus c. That leaves us with 14. Take 14 away from this side. Take 14 away from that side. And that means that c is going to be equal to, what do you get, Piwa Konke? I'm getting negative 11. Three minus 14 is negative 11. Everybody happy with that? Cool beans. Okay, so y equals, let's finish this off, 7x minus 11. There we go. Okay, now enough talking from me. You guys try this one. And I think this is going to have to be our exit ticket. Okay, so you have to determine the equation of the tangent to the curve. I hope everybody can see that. Is it big enough? Let's just make it a bit bigger, which is parallel to the line y equals x plus 2. Okay, so I'm going to be quiet. If you've got any questions, please ask me. And then, of course, a thumbs up when you're done, please. Wow, Virginia, that was fast. Good. Excellent. So everybody else keep working. I'm going to come back to the screen now. Hopefully you've written this down. Virginia, while you're sitting and waiting, do you recall that other question that I had given you up at the top? Let me just go and fetch it quickly. Where was it? Oh, there we go. Just get this down here a little bit faster. There we go. So sorry about that, everybody. I just wanted to go and get this question. Okay, so we're all busy working on that. Okay, so everyone carry on working. As soon as you're finished, give me a thumbs up. I hope my talking doesn't irritate you. But I just wanted to talk about this question with people who are finishing. Virginia, would you know what to do here? I mean, if you were asked to derive y with respect to x, do you know what to do with that numerator?
Ma'am, I think is it factorize?
You are going to factorize. Now, would you believe, Virginia, there's two kinds of factorizing that you could do with that numerator. Do you
Yes,
know what
ma'am.
they are?
Ma'am, you could use what's it called? Inspection.
You could use inspection, you could, so you could factorize the cubic. But did you also know that if you don't know how to factorize a cubic polynomial, that you can also do it using grouping?
Oh yeah, yes ma'am.
Okay, so just bear that in mind. I'm hoping that I'll have a chance to be able to show that to you guys. But yeah, you can group the first two terms together, group the second two terms together, and then you can cancel out a bracket using grouping. Okay, so I don't know if you want to work on that in the meantime. I see we're running out of time. Ozayo, done. Well done. Excellent. Okay, so we're running out of time here, guys. I'm sorry. We've only got 4 minutes left. Ozayo, if you're done, I don't know if you heard what I was saying. You can also try that question if you want to. I don't know if we're going to get a chance to go through it. And the top can be done. The numerator can be factorized using grouping or by factorizing a cubic polynomial. Okay, so I'm just going to wait another half a minute and then we're going to go through the answer to this. Okay, guys, unfortunately, we're almost out of time. We've only got a couple of minutes left, and Michaela will still need to speak to you very quickly. So I'm going to have to whiz through the answer, unfortunately. Here we go. Okay, so did you get that the gradient was 1? Okay, remember there's an invisible 1 sitting in front of the x. Cool, all right. So if we've got the gradient, that means that we then need to work out what x is. So we take the first derivative. All right, we sub in 1, we solve for x, we end up with x is equal to 1 as well. So that's a little bit confusing because the gradient was 1 and x was 1, but anyway, never mind. Then because we know what x is, we can work out what y is. So f of 1, sub that in, we get 2. All right, so I'm hoping you guys got the same answers as me. I see the thumbs ups are going up. Brilliant. And then subbing into y equals mx plus c, we then end up with the line y equals x plus 1. Look at all those thumbs ups. That's brilliant. Well done. Oh, I'm so happy. Well done. Great. Fantastic. Good work, everybody. Really, really nice. Are there any questions you want to ask me quickly before Michaela has to speak to you? Is there anything anybody wants to know? Is there something that's troubling you? No? Okay. All right. Then Michaela can speak to you. Well done, guys. That was great work.
Hi, everyone. Well done on all your hard work this evening. Yeah, so we're just doing a check-in. Can you please tell us on a scale of 1 to 10, how well did you understand today's content? Okay, wow.
Well done.
Wow.
That's brilliant. Kanya, I'm so happy because last time I think you were feeling a bit unhappy. Well done, everybody. 10, wow. 10. 9, Luyanda, that's fine. Ayomida, can you go back to the M question?
Yes. Yes. The sessions are going to be recorded.
Rekomeditswe, Avile. Okay. Ayomida, when you said go back to the M question, do you mean the orange one? Or did the one prior to that? It's fine. Okay, you sure? So these will be recorded. So if there's anything that you didn't catch, you are absolutely welcome to go back and go and look at the video again. Okay, that's it. Well done. So we'll see you on Thursday at 5 o'clock, and then we're going to be talking about cubic graphs. Okay, so I look forward to seeing you then. All right. And Kayla, do you want to share their homework with them?
Homework, yes.
Thank you.
Okay. So for your homework, you're going to go into the app and look under calculus. Once you've found calculus, you'll see that there's derivative application under there for today. Could you please do the finding the equation of a tangent, part 1 and 2, and then some prep for our next session. There's cubic graphs and factorizing cubic graphs when one factor has been given, and factorizing cubic graphs when no factors have been given. These are 2 videos. Could you please watch these videos before our next session, just as a bit of a prep so things make a bit more sense?
Okay, yeah, that's great. So that'll just help you with factorizing cubic polynomials, which we need to be able to do in our next lesson. Okay, everybody. Anyway, give yourself a big hand of applause. Well done. That was a wonderful lesson. I'm very proud of all of you. You've done beautiful.